All right, hey everybody. Welcome to the Chapter 8 review class. This is the review lecture, I should say. So this is the first of our remaining chapters as we move into the final unit. And in this unit, what we're going to be doing is bringing together all of the different concepts that we've been discussing throughout the course and combining them into looking at how firms are making decisions as they work in different markets. Let's call it that. There is a sense, if you've been doing your reading, you'll see that in some ways, Chapter 8, Chapter 9, these two chapters can probably be seen as the two most difficult chapters in the course. But at the same time, if you have been kind of keeping up with your studies as you go, really there's actually not a whole lot new that we're going to be talking about. You'll see that we have been building a set of building blocks up until this point with our discussions of supply and demand, our discussions of elasticity, our discussions of the cost of production. All of these things come together into play as we look at how markets, how firms behave in the different markets. So we start with a discussion of perfect competition, and I'll kind of go through explaining what we mean when we say that. So before we get into how perfect competition works, I think we need to talk about the overview of market structures. So when we talk about market structures, what we're saying is that when we bring buyers and sellers together in the marketplace, there are actually different forms that that takes. And in many ways, it really comes down to the level of competition that there is in any given market. Depending on how much competition we have, we will see different ways of firm operations, and so we'll kind of go into that. What is it about these markets that are different? Well, it comes down to competition, and we can actually break that out into considering the ways that the markets differ in competition. The first and easiest way of looking at that would be the number of firms that are competing in any given market. We could say that if we could look at it on a big spectrum, we could say that on one end, there may be an infinite amount of firms, and that's what this little symbol here means, is infinity. So in a highly competitive market, you could have hundreds or thousands or tens of thousands or even an infinite number, if we're talking in theory, of firms all competing with one another for those sales. And then at the other end of the spectrum, you may have a situation where there is only one single competitor, and that would be a situation we would think of as a monopoly. Um, One firm serving the market where there are no other competing firms to try to sell goods as well. So we have the number of firms that are in the market, and then we have the product that the firms are actually selling, and there can be a range. Once again, we'd look left to right, and we would say that on the far extreme, we might have firms that are producing products that are identical in every way. They're the same color, shape, size. Nothing sets one firm's product apart from another firm's. You can think of agriculture here. So if I'm producing corn, first of all, I'm probably one of many tens of thousands of corn farmers. And then secondly, if you combined our corn together, if you mixed it all into a bin, there really would be no way of telling whose corn came from which farm. It's just all the same thing, right? So the similarity of the goods being produced is identical on the one end of the spectrum, and then it can be differentiated on the other end of the spectrum, meaning maybe there's a wide sort of range or variety of those goods. Um, and at the far extreme, you may even have a good that has no, way over here, a good that doesn't have any substitutes. Not only are there no other goods that are identical or even a little bit different, there's just nothing else that compares. So different numbers of firms producing goods that have different characteristics. And then we also think about what we call the barriers to entry, which is how easily can firms get into the market if they wanted to compete also. So on this left end of the spectrum, we could say it's very easy for firms to enter. Not very, not a very big financial cost. There's not any legal barriers. If I want to compete in this market, I can just jump in and do that myself. And therefore, there's very low barriers to entry. It's very easy. On the other end of the spectrum, I put a nope here. You just can't get into that market. It's either very, very, very costly, like billions and billions of dollars to enter, or perhaps there's some kind of law, like a patent or a copyright, preventing you from being able to compete and produce the same product. And we run into both of those situations as well. So looking along all three of these different characteristics of the different markets, we could see that there might be a range. You might have many firms or only one firm or anywhere in between. Those firms could be producing identical goods or only one good with no substitute, or maybe a variety in between. And maybe it's very easy for other firms to jump in and compete, and maybe it's not. So what this leads us to are these four types of markets, and these are like extremes on the one side and the other side. On the one side, we have the perfect competition, and this is what we will study first. This is the situation. If it's a perfectly competitive market, you have many firms producing identical goods, and there are no barriers to entry or very low barriers to entry. So a very, very highly competitive market, so much so that we would call it perfectly competitive. There's as many firms as the market wants, and everybody's just making the same thing. And there can be more firms to come in if they so choose to. So the competition is kind of unlimited. On the other end of the spectrum, the monopoly, there is only one firm, like we mentioned. That one firm is producing a completely unique product that nobody else can sell. And there are very high barriers to entry. Nobody else can come into that market to compete with the monopoly. So we'll study perfect competition first, and then we'll move on to monopoly in the next review. And then in between, there's kind of, just think of it like moving along the range. And this is what we'll look at in chapter 10 and chapter 11. So monopolistic competition is like perfect competition. There's still many vendors. There's still very low barriers to entry, but we start to see some differentiation between the products. That's not supposed to be an arrow. There we go. So instead of producing identical goods, the firms are setting themselves apart a little bit. So we'll look at that. And then in chapter 11, we'll look at oligopoly, where we have a small number of firms producing goods that are similar or maybe a little bit different. And there are some barriers to entry for firms to get into the market. Maybe they do have to overcome some hurdles, but it's not impossible. So that's what we'll be looking at, but we're going to start here, perfect competition. So perfect competition, we have our definition of the market. There are many competitors all producing the same thing, and it's super, super easy to enter the market. And because of this, we recognize that in a perfect competition, all firms that are competing are price takers. And what do we mean when we say that is that these firms don't have any ability to set the price. The price is set by the market, and this is what we studied in chapter 3. Here we are looking at a market demand curve with an equilibrium, and what has happened is that the market has found the equilibrium price and the equilibrium quantity that it wants, and the firms are basically told what that price is going to be, right? So here's our equilibrium price, and we'll call it $5. So $5 is the price for this good, and the market has decided that it wants 100 billion units of this good. So huge, huge, huge amount, obviously more than any one firm could produce. We need many, 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 many firms to satisfy this demand, and the firms will be taking whatever that equilibrium price is. No say whatsoever in what to charge. So that leads us to a question. So what does the firm actually have control of then? They cannot control the price, but they do want to maximize their profits. And really, this only leaves them with the decision to make of how much they should produce. So I'm one farmer and there's 10,000 farmers. I need to make a decision at what level of output will I create. So we remember if I'm a firm and my decision is how much should I actually make, and the price of the good is given to me, then really it should be kind of an easy decision because I just need to be thinking about my profits. Um, Here we will think first of all about the total amount of profit a firm can make. And we recognize that profit is simply taking all of the revenue and subtracting all of the costs. So total revenue minus total cost is equal to profit. Fair enough. Let's rewrite that. Let's say that revenue, the money coming in, is the price of the good times the quantity of goods that I sell. So if I have 100 goods and I sell them for $500, then that's $500 in revenue, right? And then the total cost will be the quantity of the goods minus the average total cost of those goods to sell. So again, I have, what did I say, 100 units? So 100 units and $2 on average in total costs, and that means my costs were $200. Right? So however much money is coming in minus however much money is going out. We could factor this and say that this means if we take the quantity of the number of goods that we sell and then we multiply that by the price of the good, subtract the average total cost. This will give us our total profit. And we have to simply answer the question of where is that going to be maximized? How can I make sure I make the most total profit possible? So one way we could look at that question is we could introduce this fancy looking graph where I'm graphing out the total revenue that I'm earning and then looking at my total amount of cost. And don't worry too much, you won't have to be responsible for this kind of graph on your test or anything. But if I have a total revenue line, I'm just saying that as my quantity of output increases, every time I sell another good, my total revenue is going up and up and up, right? Because I'm getting the same price for every product, it's going up in a nice straight line, and it's just a total revenue line. My total costs, though, they would start a little bit high because I have my fixed costs that I have to pay even when I'm not producing anything. And then as I produce greater and greater quantities, I'm being efficient. My total costs are kind of staying low, but then they start going up quite a bit as the marginal cost increases, and my costs eventually would skyrocket. So what we see then is a range. So here's my total revenue, and here's my total cost. For the first little bit, my costs are actually higher than my revenues, and I'm not profiting. And it takes me some level of output before I even start to realize a profit. And then if I keep producing more, then I'm going to reach a point of maximum profit where costs start going over revenue again. And there's basically a range here. I can produce from about here to here and earn profit at any point. And this gap widens. At some point here, I am earning a maximum amount of profit. Um, don't worry again too much about this graph. It's not something you'll be responsible for. The key idea is that when we are producing, and I'll draw a new arrow up at the top here just to show increase in quantity. As we are producing, it takes a bit of time, it takes a bit of output to get to a profitable level, and then profits will increase and then decrease again. And this is basically the idea. There's actually a much easier way to demonstrate this. And to do that, what we're going to do is introduce this concept of marginal revenue. And marginal revenue is the one of the very few new things that we're actually going to be introducing in this unit. Marginal revenue, just like we know a marginal cost is the additional cost to produce one more unit. So the marginal revenue would be the additional the additional revenue gained from producing and selling one more unit. The change in the total revenue for one additional unit. So I'm just going to flip to a Excel sheet here for a moment. So what I've done is I've created a very quick supply and demand curve. I'm going to be looking at their supply and demand model, and we'll be looking at, oops, I should change all of these actually, 4. There we go. I'm not looking at the market, I'm looking at the firm, right? We've already established that the firm is a price taker. So yes, the market is seeing change in price with different amounts of quantity, but I'm thinking about this just from the point of view of me as a firm selling. So the market has told me that I can sell as many goods as I want for $4 each, right? So I can make one good for $4, or two goods at $4, or three goods, sell them for $4, four goods, sell them for $4. It doesn't matter. Any amount of goods that I want to make, that's what I can sell for, right? So if I'm calculating my total revenue, it's very, very easy. I take the price times the quantity, and I have my total revenue. Let's center that. There we go. So I produced one good. I sold it for $4. Fantastic. I made $4 in total. If I produce two goods and sell them for $4, then I make $4 times 2. I will accept that typo. And $8 is my outcome, right? If I produce three goods and sell them for $4, then I make 12, and then 16, and then 20, right? So my total revenue keeps going up the more goods I'm producing, and that's again what this straight line here is, just an increasing total revenue. Now, what I want to look at is a couple of other things. I want to consider my marginal revenue, and we remember that marginal revenue just means the change in the total amount of revenue I get for producing an extra good. So if I produce one extra good, my very first good, I make $4 minus the 0 I had before. Oops, equals 4 minus 0. So my pile of money grew from $0 to 4, and that means it increased by $4. And then when I produced two goods, I had $8 in total. So I take my big pile of 8, but I remember that I had 4 already, so I'll subtract that. And I see that my marginal revenue is once again $4. I have a $12 if I make three goods, but I already had 8, so I'll take that away. The change in the total revenue was once again $4. And in fact, at every point here, I can see, oops, equals 16 minus 12 equals 20 minus 16. Every time I create and sell one more good, my change in total revenue is $4. It just keeps increasing by that same amount. And another thing that's interesting here is the average amount of revenue that I'm getting per good. So I am selling one good, sorry, total revenue of $4 divided by the one unit that I'm selling means I'm getting $4 on average. If I'm producing two goods, I get $8 of total revenue. I divide it by the two goods that I've made, and once again, I get $4. And it looks like I can just do this all the way down too. So three goods, I get $12 of total revenue, which means I'm getting $4 on average. And it just keeps going and going and going. So every step of the way here, I can see that there's a few things lining up. Whenever I increase my quantity, then my total amount of revenue goes up. But there's things that aren't changing. The price is not changing for me. The price is what the market has told me. It's $4. And also, the change in my total revenue is always $4. And the average revenue is always $4. So it's like $4 is kind of consistent here. This market price represents a couple of other different things that I'll be thinking about along my curves too. So we'll put a little MR there and an AR there as well, just the short forms. So I have a marginal revenue curve and an average revenue curve, but they're all $4, which is the same as the price. Okay, so let's skip ahead to this one. So here, let's just think about marginal revenue and marginal cost. So the marginal cost curve, and this is going back into chapter 7. Remember, we have our 3 different cost curves that look like this. well, four really: average total cost, average variable cost, and fixed cost, average fixed cost. Here, I don't know if I have to write it all in, but I will. And then right up through the middle, we had the marginal cost curve, right? MC. And that was the cost of producing additional units. So if I produce one more unit, my cost goes up and up and up and up and up and up and up. And that's what this kind of connected dots line is here. It's that Nike swoosh. This is our marginal cost curve. Now, remember, in our perfect competition, our marginal revenue curve, we looked at it as being $4 no matter what level of output that there was. So it actually just formed a straight line directly across my graph. And I can tell you, and we'll explain it in a moment, that where these two curves are intersecting is the place where we're making the maximum amount of possible profit. And that should just make sense because this is me producing additional units, right? As I'm doing that, so I'm increasing my quantity. As I do that, my change in total cost goes down for a while. And then my change in total cost goes up. So it's getting a little bit cheaper to make additional goods, and then it gets I make a good as cheaply as I possibly could, and then it starts costing me more and more and more to produce more and more goods. And yet the revenue I get for each of them is staying the same no matter what. So let's just choose a quantity of 40. At $40, it's more, I get more in revenue than it costs me to produce the good. Let's do 60. I'm getting more in revenue than it's costing me to produce the good. Let's do 80. I'm getting the same amount of revenue as it costs me to produce the good. And if I go any higher than that, then it's costing me more than I'm getting in revenue, right? So cost is higher than revenue. And without even using the graph, we could just look at it this way. Whenever we say marginal revenue is greater than marginal cost, that means that there must be room for profit. So if I make one more good and the money I get for making it is more than the money it costs me to make it, then I should definitely make it, right? And as long as that is true, I should continue making more goods, right? Um, but at some point, I'm going to reach a situation where those two amounts are the same. The money I get for making the good is the same as the money it cost me to make the good. So then what happens? Well, if I kept producing, it would start costing me more to make a good than I would get in money for making it. So if that's happening, I want to cut back on the amount of goods that I'm producing. So there's a pressure here moving in both directions. If my marginal revenue is greater than my marginal cost, I want to keep producing. If my marginal revenue is less than my marginal cost, I want to stop producing and pull back. But right in the middle of these two things is the point where marginal revenue equals marginal cost. And on our graph here, that's that intersection point. Marginal revenue is equal to marginal cost, right? So the two things are the same. This means that there is a single point of output where I am maximizing my profit, and I can figure that out without looking at all of this fancy graph, right? All I need to know is that those things will intersect. So let's consider this in a few different senses. So let's look at economic profit. Right? Economic profit, we're talking about the cost of the firm and the revenue that we can get. And we're thinking back to chapter 7, are we actually making an economic profit or not? Starting with our cost curves, right? So we had our average fixed cost, our average variable cost, our average total cost, right? We just combine these two together and we get the top curve. So the question is, can I make money producing a good, and how much should I produce, right? Well, let's put all of these curves, a few of these curves here together. For the moment, let's get rid of these two curves. We're just going to ignore average variable and average fixed. We'll think about average total cost. I'm going to get rid of those just in case I need them later. We're going to think about this curve here. We're going to think about the marginal cost curve as well, and then we'll just display that with the revenue curves. So here are some situations. These, I'm a firm. This is my firm producing, and I have in all three of these a marginal cost of production, and that just means the cost it would, what my cost would be to make more units. I have an average total cost, right? And I'm also laying on top of all this that average or that marginal revenue. So let's start in the middle here. Here's a situation. I've got my marginal revenue, which is just this line that's moving directly across. And we know that the marginal revenue is the same as the price. It's the same as the average revenue. And it's all based on the demand in the market, right? So here, the marginal revenue crosses that marginal cost curve at exactly this point, which looks like it's about 70 units. So this is the maximum possible profit I can make. And the average cost of producing units, the average total cost, is this U-shaped curve that intersects as well. And here in this position at 70 units, all three of these curves are intersecting at the same point. I'm at the maximum profit because MR is equal to MC. And also I'm producing at the lowest possible point on the average total cost curve. So on this graph, we're saying a lot of things are all equal to whatever this price is, $3. At $3, this is the point of maximum profit. At $3, this is the revenue I'm getting for producing additional units. At $3, this is the average amount of revenue I'm getting per unit. And also, I can look at the average total cost curve and see that $3 is the cost of producing the units. This is an economic break-even situation, right? So I'm getting $3 on average for making the goods. I'm paying $3 on average to produce the goods, and I'm at a point of maximum production because if I was to produce any more or any less, I would be losing profit because that's where MR equals MC. Fair? Let's look at a couple of other different situations. What if marginal revenue is higher than the minimum point of the average total cost? So here's where the middle graph is, but in this case, on the left-hand side, the price is much greater, right? Down here, the price was $3. Over here, the price is $5. The market has come back to me and said, you know what? We are now paying $5 for these goods. So my cost curves didn't change. It still cost me the same amount of money to make them, but now I'm getting more money from the marketplace. So we raised the price, and we see that now marginal revenue intersects with marginal cost at a different point. And that's now, it looks like about 85 units. So I'm actually going to increase my production. And also now the price that I'm getting is higher than the average cost of producing the goods, which means that there is some profit being made for each of the goods being sold. And it would form this kind of this box if we were to multiply it out. There's an amount of profit on average, and there's the total quantity that we're selling on average too. So this is a good situation for me. Because the price has gone up, I'm making economic profit. If the price were to go down, this would be bad for me. I would now be operating in an economic loss. We can see that at this lower price, I've had to pull back on my production because the intersection is a little bit lower. My average total cost is actually higher than the average revenue that I'm getting, and this means that I'm losing a bit of money on every single unit that I make. So I'm basically kind of like a boat in a storm. I have my costs, and sometimes the market price goes up, and sometimes the market price goes down. To make this a little easier to see, I'm actually going to pull open a graph here. This is just an online website that is useful from time to time. So I want everyone to be looking at this bottom graph here. Ignore the top one entirely. That's the more complicated one that we were looking at earlier. But on this bottom graph, I am I have a marginal cost curve, which is the orange line. I have the average cost, which is the U-shaped line, and then I have this uh, horizontal line, which is the price of the good, the market demand, the average revenue, the marginal revenue. It's the $4, or in this case, it's 8. So so let's say the market decides for some reason that the equilibrium price will go up. Uh, Demand has increased because something became more popular, tastes and preferences changed. So demand increased, equilibrium price rises, and me as the firm, I see that as a rising price, right? And as that price rises, then I start producing more. Watch what happens on the quantity line. So here, the intersection is where the blue dot is. That's where MR equals MC. The market decides that price is going up, and that blue dot is at a higher quantity, right? So now I'm producing 32 units at a much higher marginal revenue. So my average total cost is this lower circle down here. And we can now see that the average revenue I'm getting is much higher than the average cost, and therefore I'm earning profit, which is represented by the green box. Now, if the market decides that the price is going down, then we see this happen, right? I'm reducing my output. Now I'm only producing 8 units, and I'm selling them at a low price of $4, but it's costing me $10 on average to make those units. So here I'm operating at a loss, right? So the market price goes up, the market price goes down. Watch what happens on the quantity line when the market price goes up. I'm always producing where I maximize my profit, or at least minimize my losses. So as the price goes up, I produce more. As the price goes down, I produce less, right? And look at what's happening with profit and loss. As the price goes up, I earn profit. As the price goes down, I take losses. And it's really that easy. So there's really just two steps. One is we need to determine how much we should be outputting. And that is going to be based on where this line intersects with that orange marginal cost curve. That will determine our quantity of output. Once we know our quantity of output, we can look to see if we're actually making a profit or not by comparing the price to the margin, the revenue, sorry, the average revenue to the average cost. Right? At low prices, we're taking loss. Average cost is higher than average revenue. At high prices, we're earning profit. Average revenue is higher than average cost. So step one, how much will I produce? Step two, is that profitable or not profitable? And that's essentially what we need to know. Perfect competition can be that easy. Um, and then all we need to really think about as a firm is, sorry, it's another overwhelming graph, but this is just cost curves with a marginal revenue line added to it. So one thing I need to be thinking of as a firm is, should I stay in business or not? So if I'm here at economic break even, everything is fine, right? I've covered all my costs, my opportunity costs, and so on. If I'm earning a profit, everything is even better, right? Now I'm earning economic profit, so I should definitely stay in business. But what happens if the market decides that the price is going to go down and I'm operating at a loss? How long can I sustain this? Should I shut the doors? Should I go bankrupt? What should I do exactly about the fact that I'm losing money, right? I can't do this forever. So I have some decisions to make. And here it's going to, we will see different situations happen. Sometimes, if a firm is taking a small loss, they will keep their doors open and continue manufacturing and be okay with losing some money. And we'll explain that in a moment. If that loss became too great, they may just close the doors for a while, lay everybody off, and wait for the market to recover and then reopen. And then in the long run, if the price is staying in a losing situation, then the firm will simply close up shop altogether, lay everybody off, not lay everybody off, but just go bankrupt and go on to the next thing, right? So how do we decide when to keep producing and when not to? It has to do with whether we can still at least cover the labor and materials or not. And this is where this second cost curve comes into play. So the average total cost will tell us if we're making a profit or not. The average variable cost will tell us if we are at least covering the materials and labor. So if the price has gone down, so let's start here at break even, right? The price has gone down. Should I stay open? I probably should because the price is still higher than the average variable cost. And that means that I'm taking in enough revenue to cover the labor, cover the materials, and there's some left over that I can use to cover the fixed costs, right? The rent and the utility bills and so on. If the price dropped a little further, that would be true here as well. If the price drops to where the line is, we are now just breaking even on labor and materials. And if it goes any lower, then we would have to shut the doors, go on a temporary shutdown, and lay people off. So, looking at this a bit simpler, I'm actually going to insert a shape. Let's put a line here. So, this is going to be my floating price line. Okay, let's make that a little bit bigger. Okay, so here is my price. Now, if the price is way up here, I'm making profit, everything is good, right? The price begins dropping and I reach a point of economic break even. I'm at the bottom of the average cost curve, total cost. The price continues to drop. I'm starting to be concerned, but I'm still operating because even though I'm taking a loss, I'm still covering wages and materials, right? And if it goes as low as the bottom point of this average variable cost curve, that means I'm breaking even on my labor and my materials. I'm not earning anything at all to cover any of my fixed costs, and it's here that I need to shut down operations, right? So this is my shutdown zone. I'm not operating at all, especially if I'm below average variable cost. If the price is down here, I can't even pay for the labor and materials. It's not enough money, right? So the firm at the here will make a decision to open the doors, at least earn some money to pay some of the rent and the fixed costs, hopefully get to break even, and then hopefully even better increase and earn profits, right? Um, so this is kind of the reasoning for having a supply curve, an upward sloping supply curve. The firm needs a minimum amount to begin producing, and then to produce more and more units, they need higher and higher prices in order to be able to do that. So if we can make that connection too. And so if we understand that, if we can look at the firm in a perfect competition from this point of view, just looking, understanding that it's a price taker and price is going up and down, and the firm is going from profit to loss and at some point shutting down, then the only other step that we need to understand is what happens then when there are profits and losses. And here's what happens in the industry. Um, Firms will enter and exit a perfectly competitive market based on whether there are profits or not. So let's start here. This is our break-even point where we have just enough money to cover all of our costs, explicit and implicit, and we are breaking even. And then let's say that the demand increases in the market. So people decide that strawberries, we found out they cure cancer. That's fantastic. Market demand increases, and that causes the price to rise. So the price is increased, and that means that there's economic profit to be made. And the interesting thing and the fun thing about economic profit is that when there is profit being made, that's like a signal to other firms to jump in and make those profits too. And other firms will open their doors and compete in the market. So the number of suppliers will increase, right? If the price went down because strawberries caused cancer, then firms will begin shutting their doors and leaving the industry because they're taking economic losses. So losses cause firms to leave, profits cause firms to join. This is a perfectly competitive market. Now, let's think about what happens when, sorry, I went a little, there we go, that's what I was looking for. Let's think about what happens in the market when firms join or leave the market. Firms enter the market, and that causes the market supply to increase. Let me grab my little pen here. Right, we're just back to chapter 3 here. Supply, just basic supply and demand. This is the entire market, not even looking at the firm, just the market. So we looked at a moment ago, profits are increasing, which causes more firms to enter the market, which moves the market supply curve to the left, which drops the equilibrium price down, right? If firms were taking losses, then some of those firms would be leaving the market, which would cause a leftward shift of the supply curve, which means that the equilibrium price would rise, right? So think about that with what we were just looking at. So let's say we're starting here, there's profits to be made, and that means that more firms are entering the market. As firms enter the market equilibrium price starts dropping. Right? And let's say it dropped very far. So the price is now going down. Firms are operating at a loss. This is causing firms to leave the market. So the market supply is shifting to the left, which causes price to rise. Right. So profits to be made, firms enter the market, but that forces the price down. And then losses are being incurred. Firms leave the market. I hope I said that right, and that causes the price to go up. Right. Profits made, firms enter, price goes down. Losses happen, firms leave, price goes up. The market supply and demand curve interacts with the curves that the firm has to work with, and eventually what we see happen is that the forces of supply and demand cause the long run price to wind up at economic break-even. So is this good news? It is, actually. So market demand increases, equilibrium price rises, market demand increases, that causes the price to rise, existing firms make profit, other firms see the profit and enter the market, and that pushes the price down, right? Back to break even. If the market demand decreases, then the equilibrium price goes down. That means some existing firms leave the market, and this pushes the price back up. So the forces are pushing the price eventually to be right here at the minimum average total cost, which means that the firms that are in the marketplace are breaking even. And it also means that the market price, we are getting the goods and services we buy in this perfect competition at the lowest possible cost to produce them, the minimum point of the average total cost curve. So this is a wonderful thing. The market is supplied with all of the goods and services it wants, being produced at the lowest possible cost, and we have maximized all of the producer and consumer surplus in the market. Here's our supply and demand model right down here. And there is no deadweight loss. We are allocatively efficient. We are productively efficient, and everything is in perfect balance. And this is why it's called perfect competition. So, okay, now I know that's a lot, and hopefully you've done your reading. And do be sure to come to the extra help classes. We can talk about this more directly with question and answer, and I can go over some additional examples. But hopefully this is helpful in working through that material, and we will see you for the next video. Thanks, guys.